Alright, this lesson is topic 18 notes. Again, these are abbreviated notes for topic 18, so you would definitely want to look at the digits lessons to see what information you're missing. So, the first definition we need to talk about is a compound event. So we're finding probabilities of compound events, which means it's a multi-step action. So we use parentheses to show that the outcomes are one compound event. For example, if we're rolling 3 number cubes, the compound events are 2, 6, and 2. So we are asked to find the probability of rolling a 2 on the first die, a 6 on the second die, and a 2 on the third die. Independent events are events in which the occurrence of one event does not affect the probability of the other event. So in that last example of rolling 3 number cubes, the first roll that I have with the number cube getting a 2 has nothing to do with the second roll being a 6. So those are independent events. Here's another example. If you choose one tile at random from the tiles that are right here, then you replace it and choose a second tile at random. The compound event is that you choose A and then choose B. So 2 events, and the first one, when you choose an A and then you put it back in and then choose a B, that first event has no effect on the second one. So the probability of picking a B before you choose the A, there are 2 B's here, and there are a total of 11 tiles. So the probability of choosing a B is 2/11. If you choose an A first, then put the A back, the probability of choosing a B after you put the A back still remains 2/11. If I had not replaced the A, that would change the probability of picking the B. So because the probability of the second choice is not affected by the first choice, these are independent events. Let's talk about dependent events next. So dependent events means that the occurrence of the first event affects the probability of the second event. So we're going to look at those same tiles from above. So we're talking about the tiles that form the word probability. If you choose A, don't replace it, and then choose B. The probability before you choose A, again, was 2/11. We already figured that part out, 2/11. But if you if you don't replace the A, so you pick the A and you don't replace it, that means the A is gone. So the probability now of picking a B is 2 out of only 10 tiles. So since the probability changes, the events are dependent. So now it's your turn to try to figure out if each event is dependent or independent. So down here, numbers 1 through 4, you should try on your own. So write either dependent or independent next to each one. Pause the video right now to do that, and once you have completed those, resume the video. So if you pause the video, you should have come up with the first one being dependent, because if player 1 chooses red, that means player 2 cannot choose red, so their choices are smaller. Number 2 is independent. When you spin the spinner the first time, it has no effect on the second one. second spin. Number 3 is also independent. Getting whatever you get on your coin has no effect on what you roll. And number 4 is dependent because I cannot pick the same student twice if I'm choosing 2 students to hand out papers. So that is dependent. And that summarizes section 18.1. And when we talk about 18.2, we talk about sample spaces. So moving on to this, to write out sample spaces, you should choose an organized approach. If it's a 2-step action, you can use a table. So if you turn your page to the next page, papers to the next page, here's an example of using a table. Write out the sample space, and if you recall, sample spaces are all the possible outcomes for rolling a number cube and flipping a coin. So when you make a table, you want to block off the first box here. These are the headings. The first one I made so that we can put the numbers 1 through 6 because that's how many numbers are on a number cube. And then the column is made up of heads and tails because those are the outcomes for flipping a coin. So the sample space for doing the compound event of rolling a number cube and flipping a coin is made up of all of these combinations. So you could get a 1 and a heads, or you could get a 1 and a tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, and 6 heads, 6 tails. So that's a very organized approach to writing out the sample space. So I want to point out that the sample space is made up of all of these possible results. Now, if it's a multi-step action, you can use something called tree diagrams. And you will recognize this. I believe you've all done tree diagrams in the past. So if you're going to a fast food restaurant for lunch, you have a choice of a burger or chicken nuggets as your main item, French fries, sliced apples, or a baked potato as a side, and lemonade, water, or soda as your drink. You are supposed to show all possible ways to order one main item, one side, and one drink. So a tree diagram takes your first possibility of your main item. So our main item, we had 2 choices, which were burgers or nuggets. So I'm going to abbreviate that. So B for burger, C for chicken nuggets. So that's your main item. And then you have a choice of one side, and your sides are French fries, apples, or baked potato. So if you choose the burger first, you could choose French fries, apples, or baked potato. If you had chosen chicken nuggets, you have those same options: French fries, apple, baked potato. And then you're choosing a drink. And your choices are lemonade, water, or soda. So off of each one, you have lemonade, water, or soda. Lemonade, water, or soda. Lemonade, water, or soda. Lemonade, water, soda. Lemonade, water, soda. Lemonade, water, soda. So it says to show all possible ways to order. So one possible way is a burger, French fries, and lemonade. Another possible order is burger, French fries, water, and you can work your way all through that list. Now, if we weren't asked to show all the ways to order and we were just wondering how many ways we could order, we could simplify this whole process by using the multiplication counting principle. And that's the next part of our notes here. And this begins section 18.3. (18.3) says we can use the multiplication counting principle to determine how many outcomes are possible. Determine how many outcomes there are for each action and then multiply those together. So you multiply your options. So in the burger and chicken nuggets example, we had a choice for the main dish. We had to pick from a side, and we had to pick from a drink. So what we want to do is we want to look at how many choices we had for the main dish, which is 2, burgers or chicken. How many choices we had for the side? We had 3 choices, French fries, apples, and baked potato. And we had 3 choices for a drink, which is lemonade, water, or soda. So if you look at all of your options, you're going to multiply your options, and that will tell me how many options I had for the whole meal. So it's 2 times 3, which is 6, times 3, which is 18 different meals. Alright, so if you go compare that to what we have in our tree diagram, right here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different ways to order your dinner, or lunch in this case. So that's what the multiplication counting principle is, and that's all what 18.3 is about. Let's go ahead and move on to section 18.4. Now this is section 18.4, and we're writing out sample spaces in order to help us find theoretical probabilities. So we're asked to write the sample space for choosing one card from the group, replacing it, so that's really important, and choosing a second card. So we only have 2 actions, picking a card, picking a second card. So when we have 2 options, we can make our table like I have here. So we cross off that first box, and we put all the options for the first card. So I'm going to say this is fish, starfish, or a star, apple, key, and leaf. So I'm going to use those letters. Fish, star, apple, key, and leaf. Now, since I am replacing it, again, that's super duper important, my choices for the second card are the same choices. Fish, star, apple, key, leaf. So the combination of picking 2 is fish, fish, fish star, fish apple, fish key, and fish leaf. Or I could have picked a star and then a fish, a star and then a star, star apple, star key, star leaf, and you get the idea of what we're doing here. Apple fish, apple star, apple apple, apple key, and apple leaf, key fish, key star, key apple, key key, key leaf, leaf fish, leaf star, leaf apple, leaf key, and leaf leaf. So if you take a look at what we're asked, we want to know the probability of at least 1 apple. So remember that this part of my table has all the possible outcomes. So there are 25 outcomes listed here. At least one apple, I'm going to identify those. So it's all of this row, or that's a column, I'm sorry, and all of this column. So we have 1, 2, 3, 4, 5, 6, 7, I'm not going to count that one again, 8, 9. So my probability is 9 out of 25, which if I convert that to a percent, I'm going to multiply both top and bottom by 4 to get 100 on the bottom. That's 36%. So I have a 36% chance of getting at least one apple if I pick 2 cards, replacing the first card. Exactly one apple means that I would get rid of this option of apple here, so that wouldn't count. So that would leave me with 8 out of 25. Multiply both of those by 4, you get a 32% chance of exactly one apple. The next one, probability of exactly one apple and one fish. So that gives us apple fish or fish apple. So there are 2 choices out of the 25. So that's 8%. And the last one, at least one apple or fish. So this one, at least one apple or fish, are all of these apples, these apples, these fish, and these fish. So you don't want to double count anything. So we're looking at all those. So I have 5 here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 out of 25 there. Multiply both of those by 4 to get the percent. That's 64%. So it would be much more difficult if I didn't have that table to figure out all those percentages. Alright, that was a summary of 18.4, and now I'm moving on to 18.5. What I'm going to do is I'm going to put 18.5 and 18.6 on a separate video because this one's getting a little bit long. So I will stop here, and you will find another video that's 18.5 and 18.6.